Howdy, everyone, and welcome to another episode of Going to Attic Space. My name is Jason Boning, and I'm the owner of Uni-Serve Air Conditioning in Houston, Texas, where we maintain, repair, and replace HVAC systems all across this great city. And today we want to focus on that replace aspect. And so, when is it time to replace your HVAC system? Now, there's a few things that I want to share just based on data that's publicly available and kind of our experience in the field. So, first off, what's kind of a general rule of thumb, if you will, for age of HVAC equipment? So, as far as what we see today, pretty much everything you can expect 10 to 15 years. Okay. So if you have an AC system, you can expect it to last anywhere from 10 to 15 years. And a lot of that, between 10 to 15 will depend on how well it's maintained. All right. How hard is it used and how well is it maintained? And that can kind of make the difference from that 10 to 15 year mark. Now, I will say this, if you go back to, say, the early 2000s, and then even in the 90s and 80s, the equipment was made to last much longer. You could expect the equipment to run 20, 25, maybe even 30 years. We've seen equipment older than that. But I haven't dug into the history or everything that was happening around that kind of 2007 to 2009 timeframe. But for whatever reason, around that, yeah, I'd say let's just call it 2008. Around that timeframe, we started to see kind of a shift. And actually the past few years, we've actually ran into a few customers where they had a system installed in, say, 2005, and it's still running great. And then they have a system right next to it that was installed in 2012, and that thing went out. So they're like, wait, what's going on here? This is actually the newer system. But we're like, well, it's just not quite made the same. And we kind of have to walk through that whole thing where for whatever reason around 2008, after that, things are only made to last in that about 10 to 15 years. So you may be thinking, well, why is that? What's happening? And so really what I think is driving a lot of this is those minimum energy efficiency requirements. And the more efficient something is, there's just things that have to take place on the manufacturing side to achieve those. So let's take, for example, evaporator coils and condenser coils. They're all about heat transfer, okay? And so to get better heat transfer, you need thinner aluminum to really maximize the heat transfer there, to be more efficient. And so we have these aluminum coils that are super thin, and we can just start to have some issues there with leaks and things not lasting as long. And so that's part of it too. The other thing are motors. So if we look at compressors and motors, those are big things that are using up electricity. And so as they become more efficient, they're just not made as strong and as durable as they were in the past. And so that's really what we see kind of driving some of this decrease in the lifespan of this HVAC equipment. All right, so if your system is getting up there in that 12 to 15 year mark, and it was made after 2008, then it's definitely something you need to start thinking about and looking at replacing your HVAC system. Now, when we come in and we look at replacing a system, there's multiple things that we're going to take a look at. Now, the first thing is the size of the equipment. And so a lot of people are like, well, hey, I have a 4-ton. What about a 5-ton? Or, bumping it up. That's something that we hear a lot of people say. Or maybe, they're like, hey, I have a 4-ton. I want to replace it with a 4-ton. But really what we want to do is we want to do what's called a load calculation. And so we want to determine how much cooling capacity is actually needed for your house. And so, it may have a 4-ton, it may have a 5-ton, or you may be thinking about increasing. Well, we want to make sure that it's sized right. Okay. So we want to look at the size of your home and then the size of the area that system is serving. So if you have 2 systems or 3 systems, or just one, we want to make sure that we get it sized appropriately. And so a lot of that depends on, yeah, like I said, the size of your house, how many windows you have, which direction those windows are facing. For example, if they're single pane windows and they're facing south, you're going to have a higher heat load because they're going to be getting constant sunlight and that radiated heat throughout the day. Whereas if they're on the north side, there's not as much direct sunlight, not as much heat, so on and so forth. And so we're going to take that into account and make sure that we size your system appropriately. Now, in the Houston area, the sizing of the system is something that is very important. If we oversize that system, we can have moisture problems. And so, or another way to put it, it can lead to having trouble removing moisture or humidity from the air in your house. And the reason why is because if it's too big, then it's going to cool the house really, really fast or faster than it needs to. Where we actually want these systems to run, maybe not a long time, but we want them to run enough to be able to remove the moisture from the air. Now, granted, in the summertime, they may be running 24 hours a day. I get it, when it's 100 degrees outside, but that can actually be a good thing to remove moisture from the air. And so it's very critical that we get these things sized appropriately. Another thing that we're going to take a close look at is the ductwork. So, there's kind of this joke that you can have, a really nice 5-ton system that operates like a great 4-ton system. Okay. And so you have the idea there is that the ductwork is so small that it only operates or only allows the system to operate like a 4-ton system when it's 5-ton equipment. And so we want to take a look at that ductwork and make sure that it supports the airflow needed for that system. And we have calculations that we use and stuff like that where we set the airflow to make sure we have enough airflow, all that good stuff. But we're going to look at those return grills. What sizes are those? What type of ductwork is connected to the returns? For example, it may be a 20 by 25 return grill and connected to a 16-inch duct or something like that, right? We got to take all that into account and know how much return we have for that system. Then we're going to look at the supply side. How big is that supply plenum? How many ducts are coming off of it? What are the size of those ducts? That is all very critical in putting a new HVAC system into your home. Now, you may be thinking, well, hey, the current one works. It's a 4-ton. It works great. Just slap on another 4-ton and let's keep going. Well, it's not always as easy as that. Once again, we want to make sure that we get the system sized appropriately. And say it's a 4-ton and that's actually what you need, then we want to take a look at that ductwork because the newer motors today are constant volume motors, and I should more specifically the blower motors. And maybe in the past, depending on the age of your system, we could actually be taking out a constant torque blower motor. And so if we're going from a constant torque to a constant volume motor, we really have to pay attention to that ductwork. Now, to kind of give you an idea of what I'm talking about here. So torque is kind of a rotational force, all right? So how much force is needed to rotate a blower to blow air through your home? And let's look at it in kind of a simpler term. So as far as force goes, if you were to have this, let's just say this big block that's 5 pounds, and then you have another block that's 50 pounds, that block that's 50 pounds is going to take more force to move if you were to push it, right? And so let's say in your ductwork, it has a certain amount of static pressure, almost like a weight against that blower motor. Well, if it has really high static pressure, it's going to be a lot harder for that blower motor to turn that fan wheel to spin to blow a certain amount of air. Okay. So the higher the static pressure, think of it as kind of the more weight that fan has to push against. So if we're going from a constant torque motor, the higher the weight, the torque is going to stay the same. Whereas with a constant volume, the higher the static, the harder that thing has to work to maintain the same amount of volume of air. Okay, so hopefully that makes sense. But the main idea here is that if we have really high static pressure in that ductwork and we go back with a constant volume motor, well, now we're using more electricity. We may be using more electricity than the old one, even if it's a more efficient motor. And so we really have to make sure that that ductwork is sized appropriately. And so, like I said, this is all stuff that we take a look at. We have tables and calculations and all this stuff that we use to make sure that we have proper ductwork to flow air through so that it gets into your home, that it's dispersed, you get good airflow, all that good stuff. Now, as I'm sure you know, in the Houston area, they build houses like crazy, right? And so the HVAC system is probably one of the last things they think about. I don't know. I'm not a home builder, but a lot of times it seems like they just throw it in there. The ductwork is squeezed between walls and between the ceiling and yeah, all that good stuff, right? And so you may have rooms where you don't have great airflow. And that's something we want to take a look at as well. And so that make sure that when we upgrade your system, we can actually upgrade the entire system, including the ductwork and airflow and all that good stuff, so that you get proper comfort inside your home. Because ultimately, at the end of the day, that's what your HVAC system provides is comfort. And we want to make sure that you're comfortable in your home. Now, we're not able to solve every single issue. You know, there's some big homes out there with rooms on the first story that's really far and all, you know, those long runs and all that stuff. And in that case, we have to look at, you know, other systems and adding maybe a mini split or something like that. But for the most part, there's a lot of things we can do to upgrade your system and help that ductwork out to where you have really nice comfort in your home. Now, okay, just to summarize a little bit so far. So, HVAC systems expect 10 to 15 years of life if they're properly maintained. If you have us come out a couple times a year and maintain it, we want to try to get it to that 15-year mark. Um, Once it is just beyond the point of where we can repair it and you do need to replace it, the airflow, that's a big thing that you want to be aware of and make sure that that's something being considered if you're going to replace your system. If you use us here at Uni-Serve, that's definitely something we're going to look at. Other things is with the new refrigerant, we want to take a look at that copper line set, check the size of those refrigerant lines, make sure that it's sized for this new refrigerant, make sure there's no kinks or anything like that. We want to make sure it's all properly insulated. I mean, I could go on for 30 minutes here on all the things that we do when we do upgrade your system. But really, my main focus today is, yeah, how long is your systems going to last? What are things that you need to consider when replacing it? And things that an AC company needs to consider when replacing it, and make sure that you get the most out of a new system. So we'll have another episode where we talk a little more detail about actual brands of equipment, and then some of the things that take place during an install. But that pretty much does it for today. And so hopefully you learned something, and we'll be back again for another episode soon. Thank you.